Right, good morning everybody. Thank you for coming on this lovely warm, oddly warm October Monday morning. What are we doing? Okay, so today we're going to carry on talking about activities. Then we may or may not get into talking about the use of threads in activities, and that will take us probably on Thursday into looking at our second Android component, which is actually what to do with kind of long-running stuff. But we'll spend most of today still looking at the basic kind of UI model of Android. And the other thing we need to talk about is coursework. Way! They all cry. Because the only way of getting you lot to do anything is to make it assessed. I've put up the first assessed exercise. The first coursework is up on, you probably don't want to go that way. No, go around. First coursework is up on Moodle. I'll talk about that a lot nearer the end of the lecture. You may say it's far too early to give you a piece of coursework, but actually, based on what we'll do today and on Thursday and in the lab session, it is really straightforward. So more of that as we go. So what were we talking about on Thursday? We were talking about this notion of tasks and activities, right? And dividing our mobile application up into a bunch of discrete independent components, each of which forms the atomic part of a particular task, right? So we're talking about, imagine if you're looking at managing your contacts, we might take that task, the task of managing the contacts in your address book, and divide it into multiple atomic activities. For example, listing my contacts, inspecting a particular contact, editing a particular contact, right? So the model here is we're trying to break down the task, not into a kind of a monolithic application, but into multiple reusable interface components. And what we're going to talk about today is how we then make sense of that, what are the implications of that, what is Android going to do with those different components, and what we need to kind of implement in order to manage that. And if the screen blowing around becomes a distraction, let me know and I'll shut the window, I guess. Okay, so we finished on this slide last time. This is this idea, right? This idea that our application, our task is they're digging up the road. So we will shut the window. We will try and shut the window. Okay, so our task is divided into multiple activities and multiple independent components, right? So we've got listing our WhatsApp contacts, having a conversation with a particular contact, sending our location to a particular contact. Okay? And the way Android manages these activities, as we began to introduce last time, is in the form of a stack. Right? So we're on this activity, say we want to talk to Jack Whitman, we want to have our conversation with Jack. We click on Jack, and rather than changing this user interface, we instantiate a new activity that is essentially on top of this one. So we build up a stack of these activities. Essentially what the process looks like. We have a particular activity in the foreground at any given time, right? The thing that the user is primarily interacting with. Activity 1. They may do something, say they want to carry on the conversation with Jack, send an email, do whatever. The next part of the task, we say, okay, we want to use this other discrete activity component that's instantiated and is added to the top of the stack. Right? Say we now want to do something else. We now want to send our location to Jack. We need the location sending activity component. That's started, it's added to the stack. Right? So we're building up this stack of activities, and at any given time, only one of them is in the foreground. Only one of them is the activity that the user can see and the user is interacting with, because we have this notion that there's one activity on the screen at any given time is making full use of the screen real estate. The Android navigation metaphor is one of navigating into this stack and then pressing the back button once you've finished doing something. Right? You've got a couple of options in Android. You basically either press the back button to go back to the previous thing that you were doing, or you press the home button to start doing another task. Right? Does that sound familiar for those of you with Android phones, that kind of interaction metaphor? Monday morning. So how that works with the stack is that when I press the back button, it merely chucks the last thing off the stack and destroys it. And by necessity, having got rid of activity 3, activity 2 is now visible, right? So that is now in the foreground for the user to interact with, right? So build up this stack. It's essentially a last in, first out LIFO stack. As we start these activities, they build up on the stack, and as I finish using them, when I've done editing or sending Jack my location, I press the back button, and the activity is destroyed, it's thrown away, and it reveals the last thing that I was doing. Right? So that's the kind of the navigation, the interaction metaphor for this stack. So this allows us to have quite a fine-grained control over the resources that underpin these activities when we're not using them. Right? So if you remember, we talked about last time, the very idea of this model is for can I carry on? Oh, didn't know I was talking. The very notion of this model is that by fragmenting the application into multiple activities, we can have a lot more fine-grained control over the resources of the application. Right? And what this means is when things are hidden, when things are obscured by something new on the stack, the operating system can manage them in order to make really good use of those resources. So each of these activities has a life cycle that we need to think about, right? So it may be in the foreground, the user might be interacting with it. It may be in the background, the user is not interacting with it. It may be destroyed. It may become visible after some amount of time. And any activity within our stack is essentially in one of 3 states. Right? And depending on what state it's in determines what might happen to it, and as it enters those states, it determines what we need to do about it. Okay? So, an activity might be considered to be active, so in the foreground, right? So there's only ever one active activity at any given time, the one that the user is interacting with. It might be paused, so it might be visible, but the user isn't necessarily interacting with it. That's kind of a niche one. Or it might be stopped. It might be obscured by another activity. Okay? And these are all the activities in the back stack and in the stacks of any other task that might be going on. Importantly, this is where Android starts being quite aggressive over its resource management, and this is true for all of the components that we'll look at. If it's paused or stopped, then the system can drop the activity from memory if it wants to, right? So it can just throw it away. It can just destroy our class, get rid of it. When activities are stopped, they're suspended, right? They're essentially hibernated in memory. They're no longer consuming any resources. There's no events being generated for them. Their user interfaces aren't generating any GUI events, etc., etc. They're just basically stopped. We don't use any CPU for them, but we do use memory, right? So we kind of immediately stop processing for them, but they're still taking up some kind of memory. And they're vulnerable to the operating system deciding to destroy them if it decides it needs to, right? So the operating system will basically use a last recently used model to say, hang on, that activity that's right back in the bottom of the stack that you haven't interacted with for a while, I need some memory for some other things I'm doing, I'm just going to destroy it. Right? I'm going to remove that, that activity or that process from memory so I can do stuff with it. So you might imagine if we're writing an application and various bits of our application are kind of destroyed or kind of unloaded at different points and then reloaded at different points, we therefore need to do something about this. We need to manage the process if we're to maintain, for example, the state of our application. Right? So as the activity transitions between these states, as it transitions from active to paused to stopped, when it's in the background, that generates a bunch of events that we need to deal with, right? Because it's basically a message to say, hey, you're now at risk. The operating system may destroy you at any given point. And we need to do something in that regard. So we might, for example, set up the user interface when the activity is becoming active, or we might try and save the state of the activity in some logical fashion when we know it's stopped, because we know it might be at risk of destruction at some point. And we end up essentially with a state transition diagram a bit like this. This diagram's from the SDK documents. There's some links at the end of the slides pointing to the relevant bits of the SDK documentation. But this essentially charts the life cycle of an activity as it's used within the stack model. Right? So when the activity is started in the first place, when it's first instantiated, the first thing that happens is it's created. Right? And you may recall from the lab that the method in which we set the user interface of our activity was called onCreate. So first the activity is created. Once it's created, it becomes visible. So then it's started, it starts to do stuff, it starts to handle various events. Finally, it's resumed, essentially unpaused. So now it's visible, it's doing stuff, the user is kind of interacting with it. They're kind of sending messages, doing whatever. Right? So once it's resumed, our activity is now in its live state. It's on top of the stack, the user is interacting with it. If another activity comes along, what happens to that new activity? What have we just said? Where does that new activity go? Yep. No, so okay, so not that it requires memory, but say in this situation, I've got an activity and I press a button to start another activity. What happens to this activity? Yeah, it's basically the new activity appears on top of the stack, and the new activity goes through this process, it's created, it becomes visible, right? And as the new activity is becoming visible, our activity is becoming invisible, it's becoming obscured by the new activity, right? So now our activity becomes paused because we've got this nice animation happening where this activity is appearing over the top, so we're partially visible, until finally we're now invisible. We're stopped. And at this point, we're stopped in memory, right? So we're kind of saved in memory, but we've got no thread, essentially. We've got no thread of execution. None of our events are being processed. We're essentially hibernating, and we're at risk of being destroyed. So potentially we could be destroyed, or we might become visible again, right? When that new activity gets chucked off the stack, hey, we're back. We can continue doing stuff. Okay. So you might imagine that leaves us in an interesting position where what happens if we get destroyed because we've run out of memory, and then the activity that's obscuring us also gets destroyed because the user's pressed the back button. What do they see? Nothing. The operating system quickly has to recreate the activity. To the user, it appears to be the same instance, ideally, But to the operating system, it's a completely new instance of that activity because the operating system had aggressively culled it in the meantime. And we'll come back to the implications in a minute. So how does this stack work? How do we actually do this? How do we actually make a new activity? We don't just instantiate the activity subclass, right? So all of this lifecycle stuff is mediated and maintained by the operating system. So a common mistake lots of people make is just to make a new activity class, to just instantiate a new activity class. But actually, it's potentially a bit more complicated than that because, as we've said, the activity might be in a different process. We might want to be reusing one of the operating system's activities or reusing one of the activities from a different application package, right? So it's not as simple as just instantiating a Java object within our own Java virtual machine. So Android introduces the notion of an intent, right, which is an object that specifies the intent to do something. Okay? And so I say, okay, I'm going to articulate what I want to do, and I'm going to give this intent to Android, and Android's going to figure out which activities or which other components are best to kind of honor that intent. So I describe an operation that I wish to perform, like starting an activity or making a phone call or whatever, and Android will figure out which of the best components it is with which to kind of honor that. And it figures out how to honor the intent by inspecting the registered manifests, right? So this is why if we forget to register our activities in the manifest, it doesn't work because Android doesn't know how to deal with our request. It doesn't know to start activities. So to start an activity on the stack, we create a new intent object, we specify, what we want to do with that, which activity we want to start, and then we tell Android to start that activity, and then the runtime basically figures out all of the life cycle for that. Because otherwise, there's nothing handling the life cycle. It's just a normal Java object. To stop an activity, we've said the user can press the back button to basically chuck the activity off the stack, or the activity can destroy itself if it wants to. So it can decide, I've done all the work that I need to do, I can kick off the destruction, the stopping and destruction process if I need to. So let's have a look at an example that may or may not work again. Okay. So, all of it, is that legible text? Yeah. All of the examples are in a Git repository somewhere. I'll put the link onto Moodle. So what we've got here is an application with multiple activities. And what we're going to show here is the use of intent to start different activities and the life cycle that's happening between them. Okay, so I've got my manifest, and the manifest specifies main activity, second activity, third activity, fourth activity. So I've got 4 different interface components in my application. I've got main activity, okay? And in this main activity, I'm handling these various lifecycle events, and I'm printing stuff out so you can see what happens. Okay, so we've got our onCreate event where we set the user interface for this activity. We populate it with a resource. And I've got a button on click activity 2 that creates a new intent. I'm being really specific with my intent here. I'm saying, I want you to start second activity, and I'm passing that intent to the application context and saying, basically, start that activity. I've got a couple of those. The second activity does the same thing. It prints out prints out the various lifecycle events on creating second activity, on destroy, on pause, etc., etc. And it also has a couple of buttons, and we'll see what that's important in a minute. Okay, so let's go to Martin activities. So here's my main activity. It's got a whole bunch of stuff in it that we'll come on to. Actually, let's go back. Okay, so we're going to click on the application. It's going to start the main activity. So what's the life cycle that we expect to happen? It's even there. Right? We expect the activity, because it doesn't exist at the moment, to be created and then started and then resumed. Right? Because it has to go through these life cycle methods as it becomes visible. So first we instantiate it, then it becomes visible. Right? So on create, on start, on resume. It's a life cycle for the activity. The activity 2 button is going to create the second activity. So can we guess what the life cycle messages are going to be? What's going to get printed out when I click that button to start the second activity? Yeah, I think we're getting along the right lines. Let's see what happens. Okay, second activity is now up. Main activity was paused. Second activity was created, started, resumed, and then the main activity was stopped. Right, so we've got the two life cycles overlapping. Main activity is paused and then stopped, so it's now at risk of destruction. The second activity was created, started, and resumed. Okay? So, I can do two things now, right? I can press the back button to return to this, or I can press the home button and start doing a completely different task, right? So, if I press the back button, the activity is thrown off the stack. Now, by pressing the back button, we've said that we don't need it anymore. So now it's actually being destroyed. So, second activity is paused, stopped, and destroyed, and the main activity is started and resumed. You don't need to recreate it because it was already on the stack. Okay? Another common problem that people run into is to say, okay, I need to get back to the first activity as part of my application. Right? I'll just restart the first activity, restart the main activity. What do you think happens if I now do start activity again when I'm in the second activity? Pauses the second activity. Yeah, but more explicit than that, what's my stack going to look like if I start main activity from within second activity? You have like two instances? Ah, yeah. Right, so now I'm back at activity 1, but my stack now looks like main activity, second activity, main activity. Right? And for the user, this is going to get really confusing. Okay, so now if I press the back button, which activity am I going to see? Second activity. Now if I press the back button, which activity am I going to see? Main activity, right? And as far as the user's concerned, they're the same. They're the same instance, right? So if I type something in here, if I type my name in here, start activity 2, start activity 1, it's gone away, right? And I press the back button, same activity, but it's back. Okay? So, not understanding the stack metaphor is a really easy way of confusing the user. Okay? And in fact, the correct way to get back to activity 1 is either to suggest that the user presses the back button, or for this activity to destroy itself. Okay? To basically remove itself from the stack. So by now I've knackered it. Right. So, by calling finish in the second activity, I basically say, I want to destroy myself. This is essentially system.exit for the activity. Destroys itself, removes itself from the stack, and now the thing that was underneath it on the stack is there. The same way as if the user pressed the back button. Importantly, the stack is not a per application stack, it's a per task stack. Okay? So, if I go off and make a phone call, if I send out an intent to say I want to start the dialer activity, these two activities, despite being completely different processes, this is not my application, this is not my process, it is the built-in dialer, these are still on the same stack. Okay? So by pressing back, we end up in my activity again. So the stack here is separate from any individual process, any individual application. And notably, the operating system killing stuff doesn't just stop with activities, right? It goes all the way to processes. So, for example, we may find that in my application, I make a phone call, right? Main activity is stopped in the background, but the process that's hosting main activity is also at risk of being destroyed by the operating system. So it may be that when I click back a couple of times and come back to this as a user, this may be a completely different process and a completely different activity than is being displayed to me. So, stack model is really important, at least to be aware of when we're programming stuff. There are a bunch of additional things that we can do, so we can essentially ensure that an activity is a singleton. We can set various kind of process affinities for various activities. So there's a bunch of ways that we can alter this stack metaphor, but by default, we've got this building activities up on the stack and then throwing them away to return to the higher level bits of our application that we need to be aware of. Okay, so let's look at these intents in a bit more detail. What I've just done is an example of an explicit intent, where we explicitly know which activity we want to construct, right? And we can refer to it by its kind of fully qualified class name. Okay? My intent is a new intent. We pass it some particular application context that we want it to be in, right? So my application, and we specify the activity class that we want to instantiate. So main activity essentially ran this bit of code and it created second activity. Very explicit. But you might imagine a lot of occasions where as a developer, I don't know the details. I don't know the package details of every class that I might want to start or instantiate. Right? It may be in a completely different third-party application, so I don't know that I actually want this particular activity class. So in that regard, we also have the notion of an implicit intent, right? Where the data and the action that we've added to that intent are used by the OS to resolve the activity in the most appropriate way. Right? And this is where the OS and the user figure out how best to honour this particular intent. So for example, if I'm doing stuff a bit more generic, right, the operating system might figure out how to honour this, which activity to start. So for example, I can make an intent, and instead of giving it the context and a specific class, I can basically give it some data and say that I want to view this web page. Right? I'm not saying which application to launch, I'm not saying which activity to launch, I'm saying I want something to honour this particular view action. Here is the data, and it's up to Android to figure out the best way of making use of that. Similarly, if I want to if I want as part of the task to make a phone call, I can set up an implicit intent and give it the data of the phone number and say I just want to be able to dial this and let Android figure out which activity is the best way of honouring this. Okay? And it's probably going to be the dialer.
Is this where Android asks you which application?
Yes, yes. And we will see that in just a minute, hopefully. So essentially what's happening is our activity is calling start activity, and we're giving it this intent, and we're sending that up from the operating system to the runtime, right? So this is an inter-process thing that's happening. We're sending a message outside of our VM, our JVM rather, and saying, hey, I've got this intent, Android, figure out how to handle this. Android is saying, okay, I'm going to look at all of the registered manifests, and I'm going to look at all of the capabilities of the registered activities, and I'm going to start up the right one and deliver that activity, the intent that you just made, for it to deal with. And if there's a choice, I'm going to ask the user what they want to do. So now what's in our manifest gets a bit more complicated, because now we can also specify which kinds of intent we want to be able to handle. Okay? So in our manifest we can articulate a bunch of filters to determine what our application, what our activity rather, is capable of handling, and on what occasions this activity should be used for different things. Right? So in our schema, we can also specify the action and the URI that we believe ourselves to be capable of handling. And if there's more than one option, we allow the user to choose. Right? So if there's multiple matches. But essentially, we're setting up a bunch of rules of things that we can handle. Okay? So in my fourth activity, for example, I've set up this filter to basically say, I'm willing to handle intents, implicit intents, where the user is trying to view something, and the URI begins with HTTP. Right? So when the user attempts to open a web page, I'm saying my activity is available to honour that intent. Okay? And that allows us to do this cross-application, cross-process reuse of these interface components, because anybody can just jump in and say, my activity is available to handle this particular request. Okay, so let's go back to my application. So we've seen it already. On-click phone call makes this implicit intent. It says, here is the action I want to do, action dial. So again, this is quite a broad action I want to do. There may be a number of things that could handle a dialing action. I pass it the data. The URI begins with tell. Right? So there's going to be a few applications registered to handle that particular intent. And then I start the activity. And the OS says, oh, okay, the best way of handling that is to start the system dialer activity component.
Is this where it comes up and asks you to pick the default app if you're getting things to handle?
Yeah. Yeah, exactly. So, in my application, activity 4, I've set up this intent filter, like I've just shown you, this implicit intent filter that is handling these viewing actions where the URI begins with HTTP. Right? And that's the same thing that the browser is doing. Okay? So, how does it resolve these two things? If I send an intent from my main activity, on-click browse, here is the URI, begins with HTTP, here is the action view, here is me starting the activity. Let me get back to the application. There are a couple of things I could do with this. Right, so it's saying, do I want to open that URI with Chrome or with Martin Activities? What's going to give you the best browsing experience? Or the WebView browser tester, right? So there's multiple matches, there's multiple intent filters in various manifests that can handle this request in an equivalent way. Right? So if I open it to Martin activities, just once, that intent has now been delivered to the fourth activity, and it can do something with it. So if I go into the fourth activity, in the onCreate method, get intent, get data, right? So the intent is being delivered to that activity. So what started you? Oh, it's this. Deal with that, right? Show that, display that URL, dial that phone number, whatever. So this is quite nice because we've now got interactivity communication via intents, right? We can stuff data into these intents, and we can send data down the stack, right, to enable our activities to do stuff. I can say, oh, dial that phone number, show me Jack Whitman's conversation, right? Here's his UID. Edit this particular entry in the address book. So we can start to chain these things together on the stack by passing data in the intents that we're throwing around. And we can do it in kind of a nicely loosely coupled fashion using implicit intents and intent filters, or we can do it in a very explicit fashion within our activity using explicit intent. Right, how are we doing? Couple more. Oh, actually, I'll come back to that. We'll do that last, because we were just talking about this. Now, if you think about it, this is quite a useful thing to have, right, is communication between activities. At the moment, we've talked about them as very discrete things, but actually it makes sense for them to be able to talk to one another. For me to start this activity, give it some data, and expect to get some data back. Okay? And this is quite a powerful metaphor because it works across process boundaries. We can send intents to other applications on the in the operating system. We can send them data, and ideally we would get stuff back. And this allows us to think about how state is at least kind of logically maintained across our task, right? Across the stack. So there's a couple of other things that we can do. We can start an activity for results, right? Where essentially we expect some data back from the activity. Okay? So if we start an activity, when it's completed or when it's finished, it will give something back to us. Okay? When we become visible, when it's finished doing its work and has destroyed itself, it will tell us the result of what it's been doing. This data is packaged up in an intent, in a bundle within an intent, and then that activity that's just finished will tell us what it's just done. Where's my slide about bundles? There we go. Oh, my slides are in the wrong order, right? So there are some limitations on the data that we can send to an activity or the data we can expect back from an activity. It needs to be in something called a bundle, which is essentially like a Java collection. It's a key value collection of pairs, where a key can be a unique string and a value can either be some primitive item or something that's serializable in quite a specific way. And this is because we have this notion that these things can cross process boundaries. Okay? Essentially, we're limited to what we can put in these parcels, in these intents, by what we can realistically communicate to another process. Okay? So if we want to send the phone number that we want to dial from our application to the dialer application, that needs to be in such a way that we can transmit it across a process boundary to another Java virtual machine. And we'll talk a lot about this later on. But essentially, this allows us to do kind of two-way communication between our activities, right? So we can't do the usual function calls that you might expect. So we're kind of limited to communicating via intents, saying, here is some data, give me some data back when you've finished with it. And this allows us to do stuff across processes. Okay, so we can start an activity, we can just let it go off and do its own thing. We can start an activity, we can send some data to it, like we've just seen with the URLs and the phone numbers. We can start an activity for a result where we expect a little bit of data back, or we can do both. Start an activity for a result and send some data and get some data back. So let's quickly look at that. So the lab exercise this week will basically be playing with this kind of stuff. So we've seen passing information to the activity. We've seen passing a URL from the main activity to activity 4, right? But now, what if we want to get some information back? Okay. Now we need to use start activity for results. We can pass it some data. We can make one of these bundle objects. We can put some data in it, and we can add that bundle to the intent and send it off to the activity. But how do we get something back? Right? Here we need to do something a bit specific. Is we need to say when we're sending it the data, we need to say who we are. Right? Because then when we get data back, it will tell us, oh, I'm activity, hey, I'm activity 3, you're activity 1, here's the answer to that request you sent me earlier. Right? Because you might imagine there might be multiple different activities starting any given activity, and they need to know which one is returning the answer. Okay. So let's have a look at that. So on click activity 3, I basically get some text, I put it into a bundle, I start that activity for a result. In activity 3, I do some work, I make a new bundle to put the result in, I put the result in it, and then I do this thing called set result, and then kill myself. What essentially that means is that I'm saying, okay, I'm going to put the result of the work that I've done in this place, and then I'm going to destroy myself, and operating system, please give it back to the activity that started. Right? That's what's happening here. This request code is used so that when main activity receives the result, it knows where it's come from. Because it could be getting results from multiple different activities. So go back to my example. So what was I doing? I'll type something in here. So I click activity 3. Main activity is paused and stopped. Third activity is started and resumed. The intent has been delivered to it with the word Martin in it. Okay. Now, this activity needs to do some work. It needs to give me a result back. So,
does the identifier for the activity that you use to get the result back, does that need to be static between applications running? So if it was to be restarted,
that's a good question. It's not the instance. It's not referring to the instance of the activity. It's referring to the class of the activity.
Right. Could you not just use its class identifier for that instead of a separate?
You could use the class identifier for it, but I don't see why you would.
What's the type of thing you use there? Is it just an integer?
It's just an integer. Yeah. So I think the SDK requires an integer, but this is essentially saying maybe I'm going to try and draw this. If I've got main activity, I appreciate this might be difficult to see. I'm just drawing boxes. If I've got main activity, it can start multiple activities. Okay. So main activity might have started second activity, or it might have started third activity. Okay? Now, when this finishes, it's going to give its result back here. How does this know where it's getting the result from? How does it know it's getting the result from this or from this? Okay, and that's what that identifier is for. That's to say, hey, I'm number 3. Here is the result from activity number 3. That's all it's for. Okay? And because this activity started number 3 in the first place, it should be expecting a result back from number 3 at some point. So, to labour the point, hello third activity, blah, 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 some text. Okay? Now, I need to do something. I need to send the result, I need to package the result into an intent, and then destroy myself, and then this activity is handed that result and said, here's the result of activity 3. In main activity, we can see this happening. Main activity has another lifecycle method that we're handling here on activity results, and here we're checking who the result has come from. Okay, so here we're making use of this request code. We're saying if the request code is activity 3, then I know the kind of data I'm going to be able to extract from this intent, from this bundle, right? Or if it's, well, there's nothing else, I'm not expecting a result from anything. So we've got this two-way communication. I mean, I think it's perhaps overcomplicating it to talk about it in this detail. And when you have a go at doing this, you know, it's basically function calling by message passing is essentially what you're doing between these activities. Okay, so we'll come back to saving state on Thursday just to finish that stuff off, because in the last 3 minutes I promised you some coursework. Okay, it's the same one as last year, but I quite like it, so I'm happy to do it again. First bit of coursework, worth 10% of the module mark, 2.5 weeks to do it. But it's mostly a forcing function to get you to do literally some of the stuff we've been talking about. Right? There's not a lot of novelty or independent thought required to do this exercise. It's literally going through the motions, putting some stuff together, building an app that does a specific thing. Right? It's literally making use of the stuff we've been talking about today and last week, and we'll talk about on Thursday as well. Okay? The application is basically a painting app. Here it is. Hey, look. You can do some drawing. The bit to do the drawing is given to you. All you need to do is put it into an activity, make some other activities, or not, make some other activities to do things like change colour. Hey, I wonder how this could be relevant to the thing that Martin was just talking about sending and receiving data, right? So it really, really is a simple application. I can talk more about it on Thursday because I'm aware of time, but there is a document on Moodle that specifies the requirements for the application, specifies the marking criteria, gives instructions on how to add in the painting component, which activities to build, etc., etc. So literally, there's a series of steps. Give me minutes. There's a series of steps, and this is just going through the steps. So don't panic. If you do read this and panic, let me know in the lab sessions. I'll talk more about that on Thursday, but start having a look at that. Oh, it's bad timing.